So we're going to look at creating diagrams of principles for the two objects that you had to do for homework last night. The first one is going to be the staple remover, and then we'll move on to the C-clamp. So we have the image of a staple remover, but we know that when we're talking about a diagram of principle, we don't really care what the object looks like. We're trying to explain how the object works. Okay, that's a huge differentiation there between these two concepts. How something works is going to look very different to how something is made. Okay, so diagrams of principle look at how something works. In our little checklist of creating a diagram of principle, number 1 states that we must list the parts in different colors. Okay, so if I look at this object, I have two main parts here. I have an upper blade or portion and a lower blade or portion. Do you see that? And they're hooked together at the end there. Okay, on that little pivoting wheel and axle. So I'm going to pick my colors here, and I'm going to change the thickness of my line a little bit. Okay, and I'm going to draw the upper one like this. Now, the reason I've got the little hook there is to actually describe the little hooks that are actually going to dig in and take the staples. I kind of find they look like vampire teeth. Okay, that's what that little crook looks like. So I'm then going to draw my other one in a different color. So far, those are my two main points. Okay, they're my major parts. All right? Now, you guys also had a spring to put in there. Okay, what's the name of the spring that you had to include? What was that called? So I've included 3 of my 4 main parts. What part am I missing? Somebody said it a while ago. What is going to link my upper and lower blade? The one thing that I am missing from this diagram in terms of the parts is the object that is going to link my upper and lower blade here. Okay, or my upper and lower lever, my red lever and my green lever in this image. So it acts as a pivot, but that is called a rivet. Okay? Now, the symbol for a rivet is what? And where could you find it? Now, in terms of where the actual rivet goes, okay, I'm just going to change colors here. Now, my rivet is going to end up going right about here. But that's not what the rivet actually looks like. I placed it there because that's where it appears in the actual design, but now I'm going to draw the symbol for that object. So now I've pretty much got all of my parts. I do have all of my parts. I don't pretty much have them. I do have them. So let's look at the checklist and see what's next. Step 2, I've got to name these parts. So I'm going to pause the video. I'm going to write out the names. Then we'll keep going. So we can see that we've labeled everything. Now, what is step 3? So step number 3 is asking us to include the motion of any and all parts. Now, the two main parts that move here are your top and bottom lever, and they rotate on the pivot. So if we're going to draw in the symbol for this, we're going to draw thin arrows to demonstrate motion, rotational motion in 2 directions or in both directions. So where does it move? It moves up here, and this one can go up and down as well. Okay? So it's not enough for you to write rotation over here and just write it once, because it doesn't tell me what parts are rotating. You need to apply the motion of arrows, okay, or to show the motion on the parts that are actually doing that motion. Step number 4 involves applying the forces required to move these parts. Because if I just sit there and stare at this thing all day, it's not going to move. Okay? I have to apply a force to actually remove these staples. What kind of force do I have to apply?
Compression.
A compression force. You were given these arrows at the bottom of the page. Where should you put these arrows? Mira?
On the top and bottom.
Okay, so here's my question then. And I'm glad that you actually differentiated between, you can split these arrows up. Okay, they don't have to appear one facing the other all the time. So what we mean by that is if we're actually going to draw this out, okay, we're going to draw a thick arrow going down this way because a force is applied in that area, and then the opposite force, and I'm going to draw over my words here, okay, is applied over here. Okay? So this is almost finished. I am now only missing one key factor in terms of, you know, what's going on with this diagram, in terms of explaining how this diagram works. Part number 5 in any diagram involves you to create or to show what kind of movement behavior your link has. Okay? And that is going to be one of those 4 link movement symbols. In this case, the rivet only allows the staple remover to translate. It does not allow it to rotate. It does not allow it to translate, but it does allow it to rotate. So that symbol, all right, change the thickness of my line. That symbol is right here. This is a symbol for free rotation, fixed translation. This is a diagram of principle. Is it messy? Yeah, a little bit. I could have probably made that a lot neater. Okay? Do you understand? Yes? First things first, when I draw the parts, I'm going to draw them as stick figures. What a lot of you did was you actually drew this as a solid sort of object. That is wrong. Okay, you don't want to do that. You want to draw this as a stick object, and you want to actually make sure that it's nice and thin. Okay, because you're not looking at how it's built, you're looking at how it works. So when we actually go to draw this, all right, we'll make it a little bit thicker. And we'll go with a color. So here, all right, and then we have an object going through like so. Is it more complicated than that? Yeah, it sure is. But for what we're going to be using it for, this is fine. Okay? So we're going to start off with our translational motion, and we know that this metal sort of rod that is right here can slide in and out of that bolt that it's attached to. There's a hole in the bolt, and it can slide in a translational motion back and forth. Okay, so this right here is where I'm going to place this arrow, like so. Okay? Yes, I'm drawing it freehand, but it is relatively straight. All right? Now, in terms of the other 2 types of motion that are here, let's look at what undergoes rotational motion. So the second type of motion we have here is the same metal rod, when it's pushed to the end like that, we can actually rotate it. It's what causes this bolt to rotate around and around. So it rotates in both directions, and the reason I am putting it down here is to show that the whole rod moves. Okay, it allows it to go around and around. And finally, the third type of motion occurs where? The final motion is a helical motion of the actual bolt up and down the C-clamp. So we're going to put that motion right here, where we draw this one like so. I don't know what I just did there. Try that again. There and there. Okay, so those are our three motions. Excellent. Now, the next thing we've got to talk about are the forces. What forces act on this? And we're going to look at the actual, you were given one force set of arrows. There are actually two forces acting on this at one time. So let's think about this. So when we're talking about the forces of these objects, there are two actual forces. The first force is a compression force here between the clamp and the bolt. Okay, so the clamp and the bolt are squeezing in on one another and they're compressing whatever's in between. But that's not enough, because we also have, in order to move this actual bolt up the C-clamp, we've got to apply a torsion force down here. Okay? We talked about the fact that this whole object here is actually a bolt, and that right here we've got the same kind of nut behavior that causes the actual bolt to go up and down. So right here we've got the incidence of a bolt with a nut surrounding it. Okay? Now, that is the actual link. Let's describe the behavior of the link. So if it allows for both translation and rotation, then it's that open symbol. Okay? So that deals with this link. Now, we would have to label, so this could be the metal clamp, right? So now you have two examples of a diagram of principles. Okay, one more thing we can add, and that's actually basically the relationship between this bar and the bolt. We know that the bolt is allowed, it allows the bar to slide from one end of the bar to the other through the bolt. And the bolt is made that it stops the bar from coming out. Okay, so this is where you would get that whole sort of kind of ball joint sort of image. Okay, so there you go. And then if that allows for translation but no rotation, we would find the actual symbol for that, which is this one. Okay, which allows you to translate but not rotate. So that, in fact, is a fully complete diagram.